Okay. And we'll start off with sharing a screen. Let me check one other thing real quick. Okay, let me do this student. All right, I'll check attendance again around the 15-minute mark. Okay, so hopefully we keep, because I think last time, I don't know, it was totally on the fritz. It's like it kept dropping my screen. I don't know, it's still kind of acting up a little bit today, but we'll do the best that we can. See, I already had something open and now it's gone. All right, that's fine. Yeah, I don't know. My device is like totally lagging. I might have to reboot it, guys. That's gonna suck. It's just not. Let me try rebooting this. Maybe that'll be enough. Because like I'm basically trying to avoid having to reboot my device, but I think I'm gonna need to, so I'll be right back. Right. Let's try this again. Let me check one other thing. Let me get these gentlemen. So, let's see, we're here. I don't know who that is. Okay, I gotta. Okay, so I just let in a Mr. Kareem. I don't have you on my roster. So I would encourage you to check your roster on Bannerweb. If you might be missing where it might say W. If you've been like administratively removed and you intend to stay, I need you to send me an email immediately with your first and last name, your M number, and then just requesting to be added back to this course. Just to this course with the time and preferably the CRN number. That's the main information that I need if you want to be added back to the course. Because when I look up,
I can do that for you now, actually, Dr. Pfeiffer.
Yeah. That's the best thing. And then once you've done it, just get back into Zoom or just get my attention so I can forward that to records.
All right, thank you.
Let's see. Let me start by sharing my screen. Seems like it's working. Yeah, sometimes I do have to just reboot the device. I'm gonna try this setting. Hopefully that helps it. It's kind of hit or miss. Let me see. There's no real major announcements. But we're entering the home stretch, right? So this week we worked on section 3.1, exponential equations or exponential functions. I think next week we have like a supplemental topic, but then next week is the last of the new material. So then I think the week after that, we're going to be like, we have the Thanksgiving break. So we'll meet on that Monday, and more than likely we have that Wednesday off. Then we come back, we meet 2 more times, right? So that week after Thanksgiving, we meet on that Monday and Wednesday. That Thursday and Friday should be the reading period. Not that we meet on Thursday or Friday, but that should be your other classes as well. Usually that November 30th or that Wednesday after Thanksgiving is the last day of classes. And then usually the first full week of December is our finals. So for our final, you can anticipate basically just similar to like our exams 1, 2, and 3, right? So the way we've been doing is just a continuation. You can anticipate the exam to be cumulative. It should become available that Sunday before the week of final starts. So I think I made it available. I think I made the exams available to like 11/11 on that Sunday before whatever week that is. But then what that means is that we're rapidly approaching the hard deadline, right? The hard deadline of Friday, December 9th at 11:59 p.m. I can't push anything back beyond that date because we have to pull the data, calculate the grades or whatever, and submit them, right? So I can't push it back beyond that. So what that means is that if you're in need of assistance, you just gotta ask. You gotta speak up. Like if you don't say anything, a closed mouth doesn't get fed. And it's like it is a different dynamic because it's remote, but it puts the responsibility on you guys. Like I try to do what I can to make myself available, but nobody's gonna hold your hand. Like you have to actively go after it. And I mean, anything is still possible. It's like you just have to decide that you want it and just take it. It's really literally just sitting there waiting for you to take it. And so like I do encourage you all, like that's why hopefully now you see why I encourage you guys to like work together. Even working together, I think is still a challenge, right? And I think that's appropriate for like this dynamic, right? With the way it's set up. It's not impossible. It's doable. Again, I feel like it's feasible and it's doable. If you just have a desire or a gumption to get it done, you can get it done. I also encourage you all to you can take this material and sit down with the tutors. You've already paid them, right? So just take it and sit down with them, and you can go line by line. The challenge with mathematics is like why I don't really think it's for everyone is you have to slow down. You have to and in this world of like social media and the internet and things of that nature, everything is so fast paced. I was about to say past face, mixing my first letters up, but everything is so fast paced, we're like in the microwave generation where, we want instant gratification. We want all the glory without putting in any other work or whatever. We want to do the celebration, but we want to celebrate at the finish line, but nobody wants to actually run the race or train for the race or do anything, right? So it's jarring. It's extremely jarring to go from that realm of instant gratification with social media and the internet to something where you literally are supposed to to do it the right way. You're really supposed to slow down, and it takes up at least 4 hours every day working on this to get any kind of sense of what it takes. Now, I don't think that's reasonable to ask of everybody, but this is higher learning. And I kind of run it the way that I do because, at some point, we have to start becoming accountable for ourselves. Like at some point there has to be some kind of line where, hey, this is my responsibility. Like, we are whatever age we are, but at some point you have to start taking accountability for yourself. It happened to me. I got really sick at one point, and I was blaming parents, society, the doctors, and I did everything that these guys said for like 10 odd years. And then it dawned on me, I was like, these doctors are just using me as a guinea pig. They have no idea what they're talking about. So I was like, my health is my responsibility. I can't blame the doctors. I can't blame my parents or girlfriend or children or anybody. It's not their job. My health is my responsibility. My experience from my life is my responsibility. I don't have nobody to blame other than myself. I had to take accountability for my actions. And I still deal with it to this day, of like trying to place blame on others. But one of the quotes or sayings is, why sharing the blame when we can share in the glory? Instead of trying to find a scapegoat or find somebody to blame, just take accountability for your experience, which is what I have to do every day, all of us. We take accountability for our experience. And then, notice those things. Like when you notice something that's like, hey, like for me, mine appears in the form of, I know that I complain a lot. So I know that when I have that urge to complain, not that I don't complain, I definitely do it. And it's not, it is what it is. But when I notice that I'm complaining, then I was like, okay, I already know that somebody else isn't going to fix this. It's come to my attention because I need to be the one to do something about it. You see what I'm saying? Complaining is one thing, but to me, the energy of complaining it's an alert. Say, hey, this thing needs attention. And if you notice it, that means that more than likely, you're the one that's supposed to put it back in order. So why sharing the blame when we can share in the glory? I just decided to go on that rant. I love that this is like live stream, so I get a copy of it, hopefully, provided that things aren't out of whack or anything. Okay. But that's neither here nor there. I just felt the urge to share that. But, and if you are trying to improve your overall grade, again, the order of priority, you definitely want to go back and try to improve your exam scores. You still get unlimited attempts, and you can earn up to 90%, on those things. So go line by line and just give it your all. Just take it. Like it's nothing wrong with it. Just take it. Like take what you want. Take what's yours. Like it's yours. It's just you have to take it. Like it's like I can't give it to you. I've tried. It doesn't work. But yeah. So prioritize your old exams as they're worth nearly 80% of your overall grade. The last thing I would prioritize are the old homework assignments, as that's going to be a whole lot of work for minimal points, right? If you really want to see it move, you want to get your exam scores as high as possible. Also be sure that, I think for this class that you follow the instructions of Dr. Lamar with the lab component. Basically, with the final grade, she's going to give me a grade. I think you can see your grade for the lab on a Blackboard. I said some tips and tricks I want to do with Blackboard. I just hadn't figured it out. I think you all should be able to like take your own attendance, right? So every time we meet, it should become available. And I think there's a way for you guys to take your own attendance. I would love to get it implemented. It would make it so much easier. There's one thing. And then the other thing is that I need to figure out how to link your grades to Blackboard. But yeah, so the lab component is really the lab and the exams. Those are the important things, okay? And again, if you need help, you just got to speak up. But if you're mute or you don't say anything, it's difficult, partly because it's remote. But even if we were in person, it's a little bit harder to kind of like get you out of it because we're in your face, but we don't have that luxury of being in your face with this design. So you have to like muster up some courage and like, if you're not going to get help from me, hopefully you have like a trusted tutor or a trusted classmate or somebody that gets it, but I'm just here to try to help you guys. Okay, that's enough of that. So you didn't sign in. Why didn't you sign in? That's fine. Let's go like this. Yeah, like when you become an adult and like you're responsible for stuff. When stuff goes left, you can try to place blame, but that doesn't solve anything. It doesn't fix anything. You gotta like, okay, this is what it is. What do we need? What are our options? Let's get it done. All right, just get it done. Like, don't even. You gotta let all that other stuff go. Okay, so 3.1. Let's take some time and get through as many of these questions as we can. Oh, come on. What does one see? We must be like Mercury retrograde or something, because like this thing is just totally throwing a fit. Every move I make, it wants to like not work. We're gonna try this again. Right here. And again, I'm just going through these questions to just fill the dead air. But if you have like something that you were working on and you have questions about it, we can talk about it. Okay. So let's see what we got going here. It says, given this function, find g of -1, right? So all we're doing here is plugging in x equals -1 and evaluating. So we're going to have 2 to the power of -1. Remember, a negative exponent basically flips the fraction. It turns it into a fraction. Okay. Let me go. Turn that off. So then if you have 2 to the power of -1, then it becomes the fraction 1/2. All right. And if anything is not clear, just get my attention. Again, this is a safe space. This is a place where, this is a lab, right? In the sense that we're here to make mistakes. If you have to get past the mistakes. You got to make enough mistakes to get proficient. That's the only way you learn. For this exponential function, evaluate when f of 3.2. So we're going to have 4 to the power of 1 minus 3.2. Whenever you have those decimals in the power like that, just use the calculator. So I'm going to break out my trusty, dusty, rusty. I can get it to work. There it is. This one. Trusty, dusty, rusty calculator. I mean, don't get me started on some of the other philosophies. Like really, if it were up to me, I would abandon, like, whatever's not working. Like, I don't really believe in capitalism. Like, a lot of stuff that's just not working, I would get rid of it if it were up to me, and just, try to hold on to what is working. So what I decided to do with this one is put in the original function in my y equals right in the upper left-hand corner. I'm working on a TI-83 plus. We have 4 to the power of 1 minus x. Okay. And like, for some reason, this 9 o'clock class is like my best one. I think it's because I'm fresh in my mind. I'm awake. So I have the most energy, the most focus. I swear, by my 3 o'clock and 4 o'clock, I'm like a zombie. I'd be feeling so bad. I'd be like, guys, just listen to my one from 9 a.m. Because that's where I'm most fresh. Like, otherwise, it's just like, it's exhausting. And I'm not even leaving. Like, I'm just sitting at home, but talking, giving my attention and energy and time. It's exhausting. I'm like, man. So all I did was I basically plugged in 3.2, and I'm going to take this result, and it says 3 decimal places, right? Matter of fact, let's go like this since we're using the calculator. It says run to 3 decimal places. So we got 0.047. After the 7 is a 3. That 3 tells us to stay where we are, right? So it's going to be 0.047. Finally figured out, 3 decimals, point. What did I type in? I typed something wrong. I put an extra 0 in there. I finally figured out what I was doing wrong with this keyboard. I had some setting wrong. And so now it's really nice. Okay. For instance, if x were 2, then basically we have 1/3 squared, right? So that means 1/3 times 1/3 is 1/9. So here I'm just going to put 1/9. It's working like a charm now. Oh, look at God. And like, I try to be a little bit animated, one, just because that's my nature. And then 2, I try to bring a little bit of flair so it's not so monotonous and boring. Sometimes I try to like launch it to like, metaphysical and things that I feel like is okay, safe to say or whatever. Find the exponential function of this form that contains these 2 points. Okay, so here we're going to be modeling. So we're basically given 2 pieces of some data, right? These 2 ordered pairs, and we're going to fit them to the exponential model, right? So we need to take some notes. I think I do kind of want that, but actually that looks better. Yeah, that's enough information. So this, does that help me? Copy of this guy. There. And I try to like keep some pertinent information, like the question ID is telling you where in the text is coming from. So if you ever were to reference this material, you'll know where to find it. So then let's hop over here. I'm gonna drop you there. I'm gonna suppress you. We are here. And again, some other just words of encouragement, you know, whatever your experience is, whatever position you're in, wherever you are, there's always a way, right? This is what we're pretty much have 1 full week of November, give or take. There is still time for you to get whatever grade you want. Like the high, you know, even if you were at the bottom, if you wanted like an A- is still possible. You see what I'm saying? You have to first know, you have to believe that it's possible. And then, you know, make a plan and take some action. Like that's all. I've had students that, you know, for whatever reasons they couldn't get full access, and so they came up to me early and they were like, okay, well, I'm struggling to gain full access. He was like, I'll practice all the while. Is it okay that I use the like 2-week trial period at the end to submit on my documents? I was like, okay, we'll give it a go. He did it. He got within that range. He submitted all the stuff he needed with his exams, the final, and all that stuff. And I don't encourage that, you know, because that's not a simple feat, you know, whatever it is. But he did it, so, you know, he gave me what I needed to kind of, that's, you know. Okay, so find an exponential of this form. Okay, so let me take some notes. Thank you. Yeah, I did check it. So we want to fit it to this form, c times a to the power of x. They give us 2 ordered pairs. So for instance, we're saying that when x is 0, so then we're going to have c times a to the power of 0. The output is 6, right? Now that one actually gives us a lot of information off the rip. A to the power of 0, this collapses to 1. So then that tells us immediately that c equals 6. So then when we plug in the other point, when x is 2, we're going to have c times a squared. The output is 96. But we just found that when c is 6, so we can go ahead and plug that in. So that we're going to have 6a squared equals 96. Divide both sides by 6. There's a 1, 36 is 6, right? And then you take the square root on both sides. Normally it would be plus or minus, but for this context, we don't let the base of the exponent be negative. So we're just going to take the positive result, right? And so we solved for A, we solved for C. Okay. So then now we got what? A was 4 and C was 6. So then our claim is that our f of x is going to be 6 times 4 to the power of x. Okay, hopefully that made sense. And again, if anything is not clear, you just have to speak up. You have to get my attention and ask your question. Okay. And then it is a good idea to test to make sure that these work. I think last time, let me see, 6 times 4. Hopefully it doesn't crash on me. Sometimes it likes to crash. Okay. Okay, so we got 6 times 4 to the power of x. Okay. Okay, for the graph the function on paper and then choose the correct graph. Let me see, how many options do we have here? Is it just the 4? Okay, I would like to do a poll for this one. There it is. Let's go like this. No, we don't need the calculator. Actually. Let me see if I go to Zoom. Check on you guys, you look good. Let's see, let's start a poll. Multiple choice is this one, launch. Okay, so there is a poll that's active. If we go back to the image. Ooh. And then I can get it here. And where is it? This one. Cool. Okay, so right now we got at least 3 people to say B. I'm just gonna go with B. All right, I'm just gonna go with it because this is what you guys chose. Nice. Okay. Sketch the graph. Okay, it looks like you should be able to see what you need to see. Let me relaunch the poll. Relaunch. Launch. Okay. Sketch the graph of this function. We have 1.8 to the power of negative x. Okay. So now, with the exponential function, we already got a vote. Normally, and the general shape of an exponential is d, right? That's when the base a is larger than 1 and the exponent is positive. So the base is already larger than 1, but the exponent is negative, right? Notice that the negative is inside our function, right? It's up there next to the x. So that's going to cause a horizontal change. It's going to cause our graph to flip horizontally, right? So then that changes it. So that means it should be either A or C. This is interesting. I would go with either A or C. So then we need to decide, well, what's the distinction between A or C? Okay. So the bigger the base, how does a larger base like affect the graph? Let me see. We got 2 for A. I feel like it's A or C. Now we could test a point like when x was -1. So if we plug in x as -1, we should be at 1.8, right? Yeah, and I think C might be a little bit off. I'm gonna go with A. Like I feel like A. I swear I was like this close from choosing C, but I was like, we need to find a distinction between A and C, right? So that was interesting. Let's try another one. Let's try another one. Okay, that's fine. Match. Okay, so let me relaunch the poll. I don't know. Hopefully you all were able to vote. You know, it says match the graph to one of the following functions. Okay, we got to vote for A. Let's see. When x is 1, we should be to what, 2? Let's vote for B. Well, I think B has the wrong orientation. I'm feeling A too. Let's try A. Let's go with that. And like the poll is interesting with it being live in the sense that it's like hive mentality. It's like what the group is thinking, even though I have about a few people that's answering, but this is okay. Use your knowledge of transformation to compare the graph of the function. Okay, I don't think this is not multiple choice. I'm gonna end this for now. Suppress that. This can come over here. Use your knowledge of transformation to compare the graph of the function given below with the graph of that. Okay, graph the given function. So we can use transformation. So we just have a generic exponential curve, but then we have this -3 on the outside of the basic function, right? It's not up there next to the x. It's like we do the basic function first, and then we have an outside manipulation. So outside manipulations, again, as a recap, generally cause a vertical change, right? By default, this is a tangent. This is a random thing, but generally speaking, by default, a math final exam is cumulative in general by default, because even if I ask things that's like towards the end of the semester, all the stuff at the end of the semester is based on stuff that we've been talking about the whole while. So I can ask a few questions from the end, and it's still going to be cumulative. The nature of mathematics is like a ladder. It's all based on the stuff before it. So it's kind of by default, it's cumulative. So like this question is talking about exponentials along with transformations of functions, right? So we should just have an exponential curve that we shifted down by 3. So I'm going to click to enlarge. Exponential curve is the bottom left one, the third row on the left. I'm going to click on that. And I'm just going to click anywhere on the curve to activate the whatever this thing is called. And all it is, only manipulation we did, first the base, I'm assuming, I don't see it anywhere. We're going to have to assume that the base is, there it is, the base is 6, right? You see it at the bottom, it says base. So we have the base is 6. And then all we did, we just do a vertical shift. We move it down by 3. So I'm just going to slide this over to 3, just like that. Hit my X. It looks good. It's just an exponential curve that we shifted down by 3. I'm going to hit save and check my answer. Okay. And again, if anything is not clear, you have to unmute yourself. You have to like try. Sketch the graph, right? More transformations. At first glance, I see a total of 3 transformations. So as a review, when we're doing multiple transformations in one go, the recommendation is to work your way from the inside to the outside. So you want to start with the innermost transformation first, do that first, and then kind of work your way to the outside. It does seem like the order in which you do the transformations affects the graph, right? But the base function here is exponential. So I'm gonna click on the exponential option and just click on my graph. The base is 2. So now working my way from the inside to the out, the innermost transformation is that -1. We subtracted a 1 on the inside. So that means it should cause a horizontal change, and it's the reverse of our intuition. So that means the graph should go to the right by 1. Horizontal shift by 1 to the right, okay? Next, we multiplied the outside by 3. Let me see. So that should cause a vertical stretch by a factor of 3. Okay. Then we added 1 on the outside, so that should cause a vertical shift up by 1. Okay. And I think that's it. I'm gonna hit save. Let's see. Right one. Did we go right one? I feel like we didn't. I feel like something didn't. Yeah. What does that look like? I think we're okay. Let's just go with it. Let's not second guess ourselves. Let's check. There it is. Okay. Let me check on you guys in Zoom. Wow. Let's finish this first. Describe how the graph can be attained from the basic exponential function 2 to the dx. Choose the correct answer. Okay, let's do the poll real quick. So we're gonna burn. Oh no! I think hopefully it saved the one that we're working on. I was trying to go like this, and I think we are still working with the same one. Okay, let's see if we can try to get this view a little bit better. That's fine, because we don't need that right now. Okay, so what were the transformations? Maybe we do need this part. Ooh, we can't see it. How can we? I guess I need to zoom out some. Let me just zoom out. I was trying to avoid that. It's a little better. Oh, now it's gone. Now just stop. Just stop. Okay. All right. I guess. Yeah, that's what we want. Okay. Okay, so now we can see our function along with the choices. Let me see if I go like this, because we don't really need that. So let me zoom in. That's fine. That's fine. Cool. I feel like that's better. Okay. So we have the original function. And let me redo this one, because I don't know if this is the right one. Relaunch. Launch. Okay. So which do you think it is? It says describe how the graph can be obtained. It says shift the graph of y equals 2 to the x, left 1 unit. Nope. There is a vote for B, so let's look at B. Shift the graph of y equals 2 to the x, right 1 unit, stretch it vertically. Okay, that's fine. And then shift it up by 1. That looks good. Let's go with B. I'm confident in that one as well. All right, cool. I mean, in the poll, move this over here. Come on. We got a few minutes. Let's take advantage of the next 5 minutes. Let's just try to maximize. It's only 5 minutes, right? We're asked to graph this and then use the graphing tool. Now, I think that together we didn't talk about E, but I definitely, mentioned this in my pre-recorded lecture. So, it's a good idea to check that out. Can you come on? I have to zoom out. You are like, okay, let me zoom out. Can I just, there we go. Jesus. It just didn't want to show. Okay. And now it's like acting up down here. I got to figure out, because I know it's some kind of scroll. Let me just close this out real quick. Because whenever I change the zoom, that's kind of what happens. Let's see. Just Trying to get this to come back. That's fine. I'm not gonna worry about it for right now. I think there it is. Maybe I got to click on a button. But anyway, we got it. Okay, so we're asked to graph this, right? We're going to use transformations. So e to the x, it comes out of, what is that? The limit, where does that come from? It's just, basically, it's just like a property in mathematics. It's similar to like pi. And it comes out of calculus where, you know, I don't know if it's like the limit. It's basically like the limit as n goes to infinity of a function. They notice that the higher n is, it gets closer and closer to this number 2.73, blah, 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 blah. Right. But for our purposes, it's just a function in the calculator. And so it's an exponential function. It's called, it's the exponential function base e. So, but it's still, the properties that we've been working on, it still holds. So we're still going to have our exponential tool. I'm just clicking on the graph. Okay, I just clicked anywhere. So then the base is e. Now we have two transformations going on here. The innermost transformation is that -4, so that's on the inside of our basic function. That should cause it to go to the right by 4. Horizontal shift right by 4. And then we have a -1 on the outside, so it should be a vertical shift down by 1. Okay, I think that's it. So we just took the exponential base e general graph. We went right 4 and down 1, and then that was it. I'm gonna hit save. I'm gonna go with it. Notice that the asymptote dropped down by 1, right? Okay, let's check our answer. I'm gonna go with it. What equation represents the asymptote? Okay, so normally it's the x-axis, which is y equals 0, but because we went down by 1, now it's gonna be y equals -1. So type in equation, y equals -1. Okay. What's the domain? So in general, the domain for an exponential is all reals. Every x is accounted for. All right. So type your answer in interval notation. So I'm going to do parentheses, negative, infinity, up to, positive infinity. Okay. So the domain is the very left to the very right. The range is the very bottom to very top. Normally for exponential, the range would be the open interval 0 to infinity, but because we shifted it down by 1, now it's going to be the very bottom to the very top is going to be the open interval from -1 to infinity. And when I'm saying open interval, I'm saying basically we need to use the parentheses with the -1, which means we get infinitesimally close to -1, but we don't actually reach it. If you look at the graph, it looks like it's touching -1, but if we were to actually zoom in, we're going to always find space between our curve and the line y equals -1. And that's an asymptote. So that's a concept. And you really wouldn't know that unless we brought it to your attention. And you got to understand that concept of asymptotes and how they behave. Okay. Let's, okay, this will be the last one. Let's just do a poll real quick and we'll call it a day. Let's relaunch the polls. You guys are awesome. I just want to see you guys do well, get what you need to get out of this, keep it moving, So it says, write an equation for this graph in the final position. The graph of this is translated 4 units left and then 7 units upward. So is it A, B, C, or D, right? So if we're moving side to side, that means we're manipulating the inside part. So that needs to be next to the X. If we're going vertically, that means it needs to be an outside manipulation. If we're going to the left is usually -x, right? But it's the inside manipulations are the reverse of our intuition. So that means it needs to be what? +4. And then if we're going up, since it's outside, it follows our intuition. It needs to be +7. So +4 and +7 looks like it's D. Yeah, see, I think I got caught by the okie doke with the minus, right? I'm gonna hit D. Yeah. Okay. Well, that was fun. All right. Quick question. I kind of want to do like a team builder. Maybe like one day we'll give it a go, like towards the end, depending on how you guys feel. I low-key wanted to play like Spy Amongst Us or Imposter Amongst Us. Like, is there a way for us to do that? Anybody know of a way to do that here in this setting? Like on Zoom or something like that? I'm just curious. We took minimal notes. I think we had one example did you guys have any questions for me? All right, so if you think of any questions, while you're thinking of questions, I'm going to go ahead and share what we wrote. And when this bar finishes loading, you'll get a copy of anything that you saw me writing. If there aren't any burning questions, I mean, we're really in the home stretch, right? I would encourage everyone to just go ahead and finish everything that's on Pearson as soon as possible. If you've done enough or all of your homework, then just make sure that your exams are in order. And then that way, the only thing that you're waiting on, once your stuff in Pearson is in order as soon as possible, there's two things that you just need to do to finish out the course. One, continue to get your daily attendance, so that's not an issue. No administrator or any that doesn't stop you. And then two, you just need to make sure to submit your final. Okay, guys, when that becomes available. If there are any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of the day, guys. Take care. Peace. All right, let's go here. Close. Thank you, guys.